The question is reverse nodes in k groups in a linked list. So given head of a linked list, reverse nodes in group of k nodes at a time and return the modified list. So what do we mean by this? Okay. So let's suppose we have a linked list of 7 nodes or 7 elements. Let's suppose the elements are 1, 1, 2, 3, 4, 5, right? And k, that is the number of elements in a group, is equal to 2. So it means each group will contain 2 elements. Okay. So we need to reverse this list in groups of k nodes, right? And return the modified list. So how many groups can we form? So how do we even calculate with the groups? First element, second element, right? It means we have 2 elements, so this can be a group, right? So we can form this as a group. One element, 2 element, 2 groups, 2 elements we have, so another group. Only one element, so we cannot form a group. So in this case, we have been able to come up with 2 groups. So this group one, this group two. So the question, what is the question saying afterwards? It's saying, okay, once we have the groups, just reverse the elements in the groups. So if I reverse it, it will be 2 and 1, then it will be 4 and it will be 3, right? And they will be connected with each other. So since 5 is alone, so it does not have anybody else to form a group with, it will be in the same fashion. And this will be my new list. It will be a list in which the group of 2 elements have been reversed. Okay. So we will approach the question in the same fashion. Like first would be to find a group. And how do we find a group? We start from the very starting of it. So let's suppose this is the dry run. 1, 2, 3, 4, and 5. K is equal to 2. This is my head, right? This is null. So K is equal to 2. So first path would be, okay, go and find the second element. That is the kth element. How do I do it? This is my first, this is my second. I say, okay, I have found my kth element, right? Once I have my kth element, what do I need to do? I need to reverse it like we did previously. I need to find a group and then reverse it. So head defines the starting, right? Instead of modifying the head, what we can do is we can use another pointer variable called as temporary head. Just in order to avoid mutating the head, we use one more pointer variable called as the temporary head. And then we have found the kth element starting from the temporary head, right? Okay. Now, second step would be to reverse it. That is to reverse the portion of the list from 1 to kth element, kth node. But if I create a function that reverses a list and pass it the temporary head, it will reverse the entire list. It will not just stop at k, or I have no means to say just stop at k, right? So what do I do in that case? So we know in order to do that, what we need to do is we need to just break this list, right? We need to break this portion. That is, this group needs to be broken from the rest of the list. And how we can do that? It's easy. Just break this list here. So what I can do is 1, 2, 3, 4, and 5. So this is again head. This is my temporary head. And this is my kth node. That is my second node. This is the link. So if I say kth node next is equal to null. If I write this way, what will happen? It will no longer point to 3. It means it will not point to 3, rather it will point to null, like this. Now it is an individual list. It is not connected to this. And if I run a reverse here, what will happen is it will reverse only these 2 nodes. But with doing this, we also realize there is one more problem. Like I have lost access to the rest of the list starting from node 3. I can no longer use it anywhere because I have lost it. So before I break this link, what I need to do it, I need to preserve the next node that will be afterwards, right? The kth node. So I can label it as next node. To preserve access to the next node that will be after the kth node before breaking of the link, we need to save it. So before I write this thing, before I can say, okay, I'm breaking the link, I need to preserve access to the next node. So I can say next node is equal to kth node next. So once I have access to this next node, now I can say I can safely break it off. Okay. What is the next step? Now I have access to the next node. I have also broken the link. I have made the portion individual. What to do? Reverse it. Reverse. Okay. I say reverse linked list. And what do we need to pass to a reverse function of a linked list? Just the starting point of it. And what is the starting point? That is nothing but temporary head. Pass on the temporary head. I have passed the temporary head. But whenever we pass, a starting point to a reverse function of a linked list, it returns us a node. That is nothing but a new head of the reverse linked list. So we will get nothing but a new head. Okay. And how will it return it? Let's see. So these reverse linked list function is not a built-in function. We need to implement it. So how will this be reversed now, right? So this two is like this, and one is one, and one will be now followed by null. And we have 3, 4, 5, and null. This portion exists because of next node. And 1, earlier it was also being referenced by temporary head. It will continue to be referenced by temporary head. And this is my head. But now this 2 is referred by kth node, but also it will be referred by new head. That will be returned by the reverse function and also the kth. Okay. Okay, so we have successfully done the reversal of first group. But still, the head, the actual head, that is the origin of the list is pointing to 1, right? And how do we know whether it is the first group or not? We know it is the first group because the temporary head is pointing to head, right? The temporary head is pointing to head, so we know it's the very first group. So in this case, when temporary head is pointing to head, it is the very first group. So what we need to do is head needs to be taken up and placed here. We need to say, okay, we have a new starting thing. So what we do is we say head is equal to new head, but applicable only to group first group. And how do we check whether it's a first group or not? This temporary head will be equal to head because 1 was the starting point, so this temporary head is pointing to 1. In the upcoming nodes, this will not be pointing, this temporary head will not be pointing to head, right? So in that case, head will be this. So once we do it, what will be the new node or what will be the new list? In that case, it will be like this. This head is taken, it is now here. Okay. Now what we need to do, the next step is to connect this one with the next node. And how do we connect it? It is easy. The connection is easy. So for this, we simply need to go forward and say temporary head, the next, which currently is null, is now equal to next node. And what it will do is it will take away the null, establish this connection. Okay. So this portion is done. We have taken the group and we have reversed it. Now we need to go forward with this group. So this group done. this group 1 first, G1 done. Now moving to second group. And how do we move to the second group? We say temporary head is equal to, what will it be, is next node. Okay, yes. Now we will move here. Once we move here, what do we do? Okay, once we move here, what do we do? I take this temporary head, I place it here. This is now here. Again, like we used to do, again, right? Calculate kth node, kth node, starting from temporary head, starting from temporary node, temporary head. Okay, this can be a function using which we calculate the, kth node. The function can be find kth, and then what we need to pass it is we need to pass it the head or the starting point, right? You can say the starting point, starting node, and which node, for example, and we pass the k. So in our case, starting from this point, we need the second. So this is my first, this is my second. So 4 will be now the kth node. Okay, here is my kth node now. What do? We know now we need to take this 3 and 4 and we need to reverse it, right? We know now we have this group. Now using this, we have formed a group. The group starts from 3, that is the temporary head, and ends at kth node. This is my group. What needs to be done here is we need to reverse it. But before we can reverse it, I need to break this. For reversing it, I need to break this. And before breaking this, we need to save the access to this 5 using the temporary node. So what I do is I move forward. I say, okay, this is my temporary node now. This is my next node now. This is my next node, not my temporary. This is my next node. And once I say it, I break, preserve next, comma, break group. Okay, I'm taking it like this. Okay, I have preserved this using the next node. I'm breaking this off here. Say now it points to null, right? The kth node next is null. This is done. What do I need to do? Now reverse it. Simply reverse it. How do you do that? Say new head, which is equal to reverse linked list, and pass the starting point, which in our case is temporary head. Okay, what would it do? It would take this link, these nodes 3, 4, and reverse them. This is my 2, this is my 1, this is my head. This is my first group that was already reversed. Now 4 will be like this, followed by 3, which will be followed by null. And this is my 5, which is being pointed by next node pointer, right? And 3 referenced by temporary head. And since this reverse link returns as the new head, which in our case is 4, so this will be pointed by new head. But important thing to note here is this green arrow, right? That joins the previous group's last element with the first element of the next group. This is still connected between 1 and 3. So there is this connection. 1 and 3, this connection is there. Okay. Now we can simply move forward and say 3 can be connected with 5 easily by saying temporary head next is equal to next node. Okay, but how do you connect 1 and 4? We cannot. So, but why we cannot connect 1 and this? The reason is because we don't have a reference to 1. There is no reference to 1. So it means, you know, we need to have a reference to the tail of the previous group so we can connect it to the new head in the next group. So we need to have a reference somewhere. So earlier here, right, we need to have a reference, right? Before temporary head moves on to next node, right? Before temporary head moves on to the next node, like this before here. Temporary head moves on to the next node, right? Before temporary head moves on to the next node, what do we need to do? We need to preserve it here. I need to do a preservation of here. This preserve it here. Wait a minute. Needs to be preserved. The tail needs to be preserved before temporary head moves on to the next group. How do you preserve? Nothing. Get one more pointer. Give it some good name like previous node, previous tail, previous group tail, or something else, previous node, and it will be equal to temporary head. Now with this being here, it will be previous group tail. So at this moment, this previous group tail would be here. Now it's easy for me to say, okay, this previous group tail next is equal to new head. And when I say so, what will happen? When I say so, what happens? I take it. So this will be broken off. This is broken off, and we will form a new link like this. This is my new link, and this link is broken off, right? This link is now broken off like this. This is broken off, and this is connected. Okay. What is other thing? Now we need to connect this 3 with 5, right? We need to connect this with 5. How to do it? Say nothing but temporary head next is equal to next node. What happens? Null gone. You are connecting it like this. And so this has also been, this group has been reversed. Okay. But as we have just seen that we always require a reference to the tail of last, group. So what we can say is previous group tail is equal to temporary head. And what will happen with that is it comes here, take it, it will be here now. Okay. Now temporary head will move on to the next position, right? Temporary head moves on to the next position. It's nothing. Okay, let's redraw the list once. We have 4, we have 3, we have 5. This 2 is reference by head. One has no reference. Okay, 3 to 5. This is now here temporary head because we say temporary head is equal to next node. Okay, and this is also the next. Also 3, that is the tail node of the previous group, is being referenced by the previous group pointer, tail pointer. Okay. Again, starting from this, the position from where the temporary head is, we need to find k nodes. But how many nodes? So k in our case right now is 2. So are we able to find two nodes? So 5 is one node and second node is null. So it means at this point we don't have k nodes. So it means we are not able to create a group. So whenever we are not able to create a group, what do? Can we create a group? We cannot. So in this case, the kth node is equal to what? Kth node is equal to null pointer, null pointer. And whenever the kth node is null pointer, we know this is the end, right? This is the end. And what do we do in this case? Like whenever it is the end, do we need to do anything? Let's see. Okay, it is connected, right? It is already connected. Okay, so in this case, we don't need to do anything, right? In our case, so we can simply break off. So we can simply break off the loop. And now let's see where is loop going? Like what is the loop? Like what is the loop? Loop is we will continue to move till temporary head is not equal to null pointer. Because if we see clearly what is happening, it is the null, it is the temporary pointer that is moving, right? And for the last case, for the last group, it will not be able to find any group and it will eventually break off. So this was my first group that we created. This was the second group. This was, so at this point it was not able to create anything and just broke off. Okay, now let's come to individual problems like lattice. That is the first problem would be find the kth node from list. And if it does not exist, we return null. How do we do that? We say 1, 2, 3, 4, maybe 5. Let's suppose key given to me is 2. And what would be passed to me for the list? It would be nothing but the head. Now I know I cannot modify the head, right? Because I never modify the head pointer to a list. So instead I will create another pointer that we call as travel. That stands for traversal. And I also need to have an integer variable that basically stores the number of nodes I have visited. Initially I have not seen any node, right? I say count is equal to 0. Now what do I say? I say while trav is not equal to null pointer. It means, right? It means we have not reached to the stage, right, in which I have exhausted the entire list, right? While trav is not equal to null pointer, we say plus plus count. Okay, and if count is equal to k, it means the node that I'm currently pointing to is my actual needed node. So I can return the trav. Okay, and trav will move on to, okay, else, or we don't need to have an else, or we can say simply trav moves to next. Next. Okay. Now, few important things to note here is plus plus count. Why it is so? Initially, is trav equal to null pointer? No, it is not. And what is my k? K is 2, count is 0. So I'm here, right? I'm here and say, okay, I'm saying, okay, now count is not 0, count is 1. And now I will check whether this 1 is equal to what has been passed to me. It is not. So I simply move trav to this place. Trav is here. Now it moves to this place. Okay. So it is 1. So it is, you know, pre-increment. So it becomes 2. Now I will check with this 2. Is 2 equal to k? Yeah, they're same. So I just return this, right? This is my kth node and it is done. This is my first thing, right? Okay. Now also let's assume in this way. Let's suppose my only having three nodes, right? Let's suppose I'm only having three nodes, and the key that I have to find is equal to 5. The key that I have to find is 5. What happens in this case? Let's try to see that. Initially, we starting off it head 1 to 3 and k is 5, count is 0. Trav is not equal to null pointer yet, so count is 0. I move into the loop, I am plus plus count, it becomes 1. Is 1 equal to key? That is 5. No, it is not. So we cannot return it. Simply move trav to the next position. Trav is here. Is it null? No, it is not. Count will increase. Count becomes 2. Okay, 2 equal to key. No, no way. We cannot return move trav. Here, can we, is it equal to k? It is not. Incremented 3. So we cannot return. Trav becomes null. So trav has become null now, right? It has not been able to reach here and now it is null. So what do we do in this case? So it means once we are out of the loop and we have still not reached where we wanted to reach, right? What do we do in this case? We simply return null pointer. Okay. So if this is a function find kth node, if you are not able to find the node kth node in between the while, and once we are out of the while and we have not got we have not returned, so we know we have not matched any of the conditions and we will return a null pointer. This will be true for the last group if in case the number of nodes in that group are less than what is given in the k, right? So using this we can find the kth node from the list. Okay, so this was one sub problem. The other sub problem is actually okay, we had reversing the list. How do we reverse a list? Second sub problem is reverse linked list. That also takes a head, maybe list star, that takes the starting point. Consider this is my 1 2 3 and this is pointing to null and this is head. So always remember, whenever we need to reverse a linked list, we need to take a node, you know for the sake of reference, and that we call as the previous node. So that would be node star previous node. Initially there is no previous node, so we can take it as null pointer. So don't get confused with null and null pointer. So eventually they mean the same thing. Just you know, in modern C++ we use null pointer, and in the older versions we are able to get that working with null. So okay, so right now the previous node is null pointer. How do we reverse this, right? I'm at head. Again, the rule of thumb: never mutate the head. Always create another temporary traversal and maybe start using that. So creating temporary, I better prefer the travel cell, trav node, right? Starts with head, and till when we do that reversal, till it is not null, while trav node not equal to null. What do we do? Okay, so this is my head. Let's now try to visualize what we are trying to do. Control C, Control V. This is it here. Also give it one more thing, that is temporary, that is trav. first thing, need to break it off. Break this link from 1 to 2, right? Because in the new list, if we see clearly, if I reverse it, like what would this be looking like? It will be looking like 2 followed by 3 followed by 2 followed by 1 followed by null. So this one should be now pointing next to a null, right? Okay. But if I just go forward and point, if I write trav.next is equal to null, what will happen? I will lose reference to this too. Then I will not be knowing like what is then afterwards. So preserve this thing, right? Use something and preserve it, like next node. So maybe node star next node. Initially it can be null pointer, that's nothing wrong with it. So we can say next node is equal to trav node next. Great, we have preserved this thing. Now we can, go forward and break this like this. By breaking this, and and where does one need to point to, right? It needs to point to null, something like this. And how do we do that? We say trav node next is equal to, but we also have to understand one thing. Here it is null, but in case of 2, it will not be null. It will be 1. So remember, we have taken this previous node here, and which is initially pointing to null pointer. Why not use this? Use it as previous node. Okay, this thing is done. This is pretty much done. But when I move to 2, it needs to do a backlinking, right? How do you backlink it to 1? Store that reference somewhere, right? And how do I do that? I say previous node is equal to trav node. So what will happen? This is my previous, right? This is my previous node now. This one is my previous node, right? This is my previous node. Okay, this is done. This is pretty much done. Now what do I need to do? I need to go to second element. Trav is equal to next node. But can trav do a next node? No, it cannot do a next node. Why? Because trav's next is nothing. Trav's next is nothing but null pointer, right? Right. So how do you move to the next thing? Using the other reference variable that we created, that was the next node. So trav node is equal to next node. And once we do it, let's see what we can make up with it. Okay, it is going to be 2 pointing to 3 pointing to null, and this will now be trav. And what is this pointed by? Previous node. Okay, next node is equal to trav next. And where is that? So it means this is my next node now. Okay, now trav next is equal to previous node. Great, like this. Formed a backlink. So this no longer exists now, right? No longer exists, only the backlink. Trav node ka next is equal to previous node. Previous node equal to trav. Previous node here, now coming to 2. Great, because it is already done the backlinking, so no need of having a previous link now. That is already done. Trav node is equal to next node. Great, moves here, continues, right? So what will happen here? Again, previous node, right? Nothing. Moves, first of all, it breaks it off. So next node will be where it will be null pointer, right? Next is now null pointer. And null pointer. This trav has a backlink it now. Like this, once it has, you know, previous node is equal to trav now. So here, right? Trav moves to next node, right? This is the situation now. Now trad is equal to null, so out of loop. But at this point, what is my new head? What is my now new head supposed to be? Is it supposed to be trav next or what? It is supposed to be previous node. So whenever we have a reverse function, return previous node, because that is the node that is actually the head that contains the head. That is the node that contains the head, right? Okay, okay, this is done. Now we will try to code it up. Okay, we have it here. So first of all, we need to define a linked list. Let's create a linked list. How do we do that? We will create a class. We say maybe node, and node has two properties. Let's create them public for now. One is int data. Another is reference to the next node, that is node star next, right? We need to have a constructor. We have node, we have int val. Now, and another is the next pointer, that is again node star nxt, and then we need to initialize it when we call the constructor. So data is equal to val and next equal to nxt. But one more addition we can do here. Let's suppose if we do not pass it, that by default it should be null pointer. Okay, this is first thing. Second thing would be, so instead of writing it, let's create a utility function that copies a vector into a linked list. Copy vector to linked list, and what we pass it is we pass a vector of type integer by name vec, right? And how do we create a linked list now? We simply create a linked list by keeping a reference to head, right, and a traversal. So node star head, which is equal to null pointer, and node star trav is equal to head, right? We say now we have to loop through the vector, right? We say for auto element of vector, right? We say if, and let first of all we need to create a node, right? Node star new node, or we can even call it a temporary node, is equal to node. It's a constructor call and pass in the data, and we pass it the null ptr. Okay, we say if head is equal to null pointer, it means it is the very first node that we are creating. What do we do in that case? We say head equal to new node, and similarly traversal will be equal to new node. But let's suppose there is already one, head. It has a head. What do we need to do when we create it? What can we do? And that will be pointed by traversal. So in that case, we need to connect that node to the new node that we have created. We can say trav next is equal to new node, and this trav will be now new node, right? Trav next and new node. This is good. And once we have done everything like this, right, we will return the head. So this is a utility function that basically copies, you know, a vector to a linked list. We can also create one more utility function to print a linked list. Again, it will take nothing but node star head. So here we don't need to keep, we can always keep our trav, which will be head. We say while trav not equal to null pointer, what do? We do cout trav, and what is it is the data property, and just give it some space. C out and L. Let's see. First thing is define your vector. We say, let's suppose my vector of type integer VC is equal to 1, 2, 3, 4, 5, 6. Or let's keep it only up to 5, right? And we say node star linked list, which is equal to copy vector to linked list, and we are passing it a vector, right? Now let's try to print this linked list. Let's see, print linked list. Okay, and what is my linked list? It's my LL. It's nothing but LL. Let's try to give it a run and see. Okay, okay, we have an error. Cannot convert node to node star, and where is it? Legs 21. Because I think we have forgot to use a new constructor here, only new here. That is the reason. Again, it is saying, okay, we are having a void and passing it, so it's like node star. Okay, so it means whenever we see in this kind of an error, it's because uh, we are not, it means like the maximum buffer out is out. It means it's doing something repeatedly. So possibly because we have not, we are not moving somewhere. So in this case of while you see is just doing something but not moving to the next pointer. So trav is equal to trav next. And okay, now we see 1, 2, 3. Now we see 1, 2, 3, 4, 5, right? So what we have done is basically we have been able to create a linked list that is 1, 2, 3, 4, 5, right? Now we know. Uh, now we can move ahead and create our very own, new linked list that basically reverses k groups. Okay. So if we ever create such a function, what does it return? It always return head to the new list or the modified list. So in our case, we have a function node star reverse k groups. It takes starting of a list, so node star head, and it will also take k, that is the number of nodes in a group. Okay, so without mutating the original head, we will keep a reference to new head as node star temporary head, which will be initially equal to head. Okay, and we know what do we need to do next. We also know we need to keep like a previous node, which maybe initially we new null pointer and node star next node null pointer. Okay, I remember these two things, and these are very common. We can always take a previous and next node in any of the cases. We also need to create some utility functions in our case and test them first, right? So first utility function that I will create is node star, you know, find kth, I need to find the kth node. What do we need to pass in? We need to pass in starting point, that is the head, and int k. Uh, as we have just seen, we will use something node star trav, which will be head and count variable to do it. We say while trav not equal to null pointer, right? And plus plus count. We say if count is equal to k, we know this is the actual node we are interested in, so we return the trav. Otherwise, move forward. Trav is equal to trav next. But let's suppose in case k is greater than length of list, it will happen when the key is greater than the length of list. So what will happen is we don't have a kth element, so we return the null pointer, right? Let's try to run this function only. So let's say how do we run this? How do we test it? We say we have this print. We say node star kth node is equal to find kth node and then pass in the head, right? That is the linked list. Now, and also we need to pass in the key. So let's suppose initially I see what is my second node from to for this node list, like 1 2 3 4 what is my second? I know it's 2 only, right? So if I do this, and how do I check it? So I do a C out and say kth node and what is the data there, right? And I simply run it. I'm expecting to see 2. Yes. And if I see what is my fourth node there, right? It should be 4. If I say what is my seventh node, you see there are only 5, there is no seventh. It should be a null pointer, maybe 0 in this case it will give me. Okay, it is, it has just collapsed because it is collapsed because now how do we check it whether it's right or wrong? We say if kth node is equal to null pointer, just see out null pointer, otherwise just give us the data. So it should say me, oh, I'm a null pointer, you're expecting too much out of me. Still okay. So then you need to have else here also, otherwise return above that. Right. Okay, so it means it is, so let's suppose if I try for the last element, that is I say a group of 5, so it should give me 5. Okay, perfect. It means this function is working well enough. Okay, moving on to the other function, utility function that I need to create is for the reversal. Node star reverse linked list. It also requires a starting point. That would be node star. How do we reverse? We just realize we need a previous node in this case, which can be null pointer, right? And we also need something called as a traverse pointer, which traverses trav node starts is the head. We say while trav node not equal to null pointer, what do we need to do? So if we break the previous link, we also need to save the next. So node star next node. Initially we can keep it null pointer, not nothing to worry about. Next node is equal to trav node next. Now we can safely change its next previous node. Now previous node becomes the traverse node and trav node will become the next node. Once this all has been done, we know trav will be pointing to the null pointer, but what will be pointing to head? It will be nothing but it will be the previous node. Okay, how can we check this? The way we can check this is print linked list was linked list. So I'm expecting to see 1 2 3 4 5 5 4 3 2 1. Not necessary errors. Okay, so it means this also works. So let's suppose instead of reversing the entire list, let's suppose I only take a portion, right? We can take the end of the portion. So let's suppose 3 4 5. So I say kth node starting from 3 and pass in the kth node. So 543. So it means, yeah, both my utility functions are working. So it means both my utility functions are working as expected. I just need to write a function which does it. I think we already have this reverse k groups, right? Okay. So I would be like while, okay, while temp head not equal to null pointer. In that case, what is my first step? Step number one, find the kth node, right? Find the kth node. So I can be like node star kth node is equal to find kth node, pass in a list, right? Starting point of a list that will be temporary head, and what is k? K is same as I pass on. So if kth node is equal to null pointer, it means no more groups. Do we need to do anything? Let's check that out later. Else, what do we need to do, right? We have this kth node, right? Uh, Step two would be so step two would be, so we have to imagine, like we understand this way, the temporary head is the starting, kth is the end. We have the two things, like I need to break it off. I break the portion from temp head to kth node from rest of list. How do I do that? And if I do that, what will happen? Before that, preserve the next. So I say next node is equal to kth node next. This is done, preserved, free to break, free to break. How do I break it? We say kth node next is equal to null ptr broken. Now can reverse, not broken. Now can safely reverse the portion. So let's do, and we know whenever we reverse it, we always return the head of the reverse linked list. So return node star new head, which means it is the head of the reverse linked list. So reverse linked list, take the list. So it will be temporary head. Okay, I have taken the temporary head also. Now, what do we do? We just need to check if it is the first head, because check if it is the first group or not. How do we check it? We say if temporary head is equal to the head, that is the original head. For the first group, these two will be the same, and in case it is the case, we won't have a previous, right? We won't be having a previous. In this case, what would happen is you can say like the head will point to new head, and what will happen is to previous, right? Previous node. Okay, let's leave it like in that way. Head will be the new head, and in it, if it is not the case, like it is not the same, then what will happen is previous node, because at this moment of time, the temporary head will be the tail of reverse thing, right? It will be the tail of reverse. So we need to make sure the temporary node stores this, right? This is like this. This is done. Temporary node for this case, if it is the case, so is equal to this, right? Else what we can say is, right, it means it's not the first thing, right? What do we do? Now we have two connections to make. One connection is from between, so one connection would be from previous, from the tail of the previous to the head of the new, right? That is my first connections. How do we do that? Say previous node next is equal to what? New head. This connection is done. And what is the second connection that needs to be done? That is the tail of the current group to the head of the new. So how do you do that? We say temp head next is equal to temp head next is equal to next node. Do we store somewhere next node? Yes, next. Okay, we have it. Next node is here. So in both of the cases, this is done, right? So this is, I think, pretty generic also, because temporary head next will be, because it will be moving. Only the thing would be previous node will be now equal to what? Previous node will be now equal to the temporary head, and temporary head next is equal to the next node, right? And temporary will move to next group, move to next group. How do we move to next node? Temp head is equal to next node, and this would be done. And suppose in this case, let's suppose we have not been able to find the, what do we have in this case? Let's say, just let's say by break, don't remember, can we say return head, let's say, okay, let's try to print the linked list that is reverse k groups, pass in the linked list and say maybe bunch of two, let's see, okay, bunch of errors. Uh, no, this was not at 56. Okay, the reason for this is, okay, these to be need to be taken up because that's the way C++ works. So anything that we're using needs to be like above it, otherwise it will give this error. Don't know. Okay, 2 1 it has taken, and 3 4 it is done, and then we have 5. Okay, seems good enough. Let's see, if I say 5 and 6, then both should be returned, reversed. Okay, and let's see if we say 7. So 7 will not be done. 7 should be there. Let's suppose in a group of 3. So first three groups, see, 1 2 3, it is 3 2 1. Then we have 4 5 6. This is 6 5 4, and 7 is 7. Even if we take 8, then 7 8 is not supposed to be, taken off, and it will work. Okay. So yeah, with this, I think we have a working code. And to summarize up, what we have done is basically, so like, given a linked list 1 2 3, 4, 5, and 6. First of all is find a group. Like when we find a group, we need to have two things. One is the starting point, that will be temporary head, right? And we will need to have a reference to this, that is the tail of this group, right? This is something that we will be needing, and usually the other thing is, let's suppose we are in a middle of something, right? Let's suppose we have it like this. Suppose we have k is equal to 2. K is equal to 2, so it means there will be groups, right? There will be groups like this. This is my first group, right? This is my second group, and this is my third group. First thing is, like, if I reverse this thing, right? If I reverse the second group G2, I'm interested in G2. How do I do it? It is in G2. First thing is, I should be able to reverse it, and for able to reverse it, I need to break this link, you know, and make it null, and then reverse it. Once I reverse it, it will be like 4, 3. Also, this 2 will be connected to this 3, and this will be true, like this will like be this even that way, right? This will be pointed by new head, but we need to change it to this 2 needs to now point to 4. The only way to do this is to have a reference to this 2 somewhere, somewhat have a reference. So use some reference like previous head or previous node or something like this, previous tail or something, or a previous. Also, when you break this, remember to keep a reference here, that is like next, right? And if we have like this reference, we can simply do like, and this will always be my temporary head, right? So starting of the group will be my temporary head. When I reverse it, this will be my new head. This will always be pointed by new head. And then what I need to think of is, uh, I need to think of my right side and my left side. My left side, I need to have a reference to the, tail node of the previous group. That is this. Always keep a reference to the tail node of previous group, and always keep a, reference to the new uh, summary, right? Keep reference tail of previous group of start of next group. So these two things we need to keep care, take care of. And other than that, we know it is simply like finding the kth and reversing it. So in terms of complexity, if we talk like what is the time complexity in this case, the time complexity will be, let's see what we are doing. You know, for every group, like depending upon the number of groups, right? For every group, we are doing certain function, that is finding the kth, and finding the kth, we perform, you know, k, uh, you know, k levels. So we move k nodes, right? For every group, k nodes, and then we reverse it. That also takes k, right? But actually, how many k's are there? That would depend upon if we have a length divided by k divided into 2 times k. For example, let's suppose I have 5, length is 5, and the k means the number of nodes in a group are 2, right? That is 5 by 2, that is 2.5, but we will take 2, right? Because the remaining we don't do anything, and for these remaining I need to perform two tasks. One is to find the kth element, that would take around k steps, and then again would be to reverse, that would again take k, so it will be 2k, so it will be 4k, right? So for any length, right, it will take 4 number of k, so it is depending upon the k. Okay, I think with this we are done.